Good afternoon and welcome to the world-renowned chemistry lab at Herscher High School, and thank you to Mr. Elliott and the school for letting me use this for a video for the Limestone Library. Austin had asked me what I had that I could show you guys for a Christmas type experiment or demonstration, and it's been years since I have done this, but it's a Christmas lab that I used to have the students do right before Christmas break. Then they moved semester exams to right before Christmas break, so we wound up not doing this lab. Anyway, it's a chemistry Christmas lab, and I have the directions here. I'll show you the directions and the ingredients. I'm not sure how easy that is for you to read that, but the materials there, it calls for one thin sheet of Al, or aluminum foil. If you're in Britain, you might call it aluminium foil. So we have that over here. It's not necessarily to get it exactly 30 centimeters by 30 centimeters. 60 milliliters of C12H22O11, which of course is sugar, the beaker there. 30 milliliters of maize carbohydrate, which a lot of people have a hard time figuring out. That is just corn syrup. 7 grams of hydrogenated bovine lactate, which is just about a pat of butter there. 60 milliliters of legumes of Arachis hypogea, which is peanuts. And it does say remove the ovary wall first, so I have had some students that have gone ahead and thrown the shells in there with it, but I don't particularly like the flavor of it with that. 15 milliliters of H2O, of course water. 1.5 grams of NaHCO3, which is baking soda, and 0.35 grams of NaCl, which is sodium chloride, just almost a pinch of sodium chloride. And what this lab is supposed to do is make peanut brittle. Not very many people get that right away, but I kind of scaled it down and wrote it in technical terms, so they would have to use a bit of their chemistry knowledge in order to be able to do this. So the other equipment that we need, a device for measuring average kinetic energy, thermometer, a 600 or 1,000 milliliter beaker. I've actually opted for an 800 milliliter one here. The heating device, named after a famous scientist, would be the Bunsen burner, and of course support for that device, a silica-based container that I can put on there, the beaker, and a silica-based rod for agitation purposes. I do have a stirring rod, but I tend to stir more with a thermometer anyway to check it, as long as I'm not scraping the sides and things. So first direction there is to place the maize carbohydrate, sodium chloride, water, and sugar into the silica-based container and apply heat until the vapor pressure equals atmospheric pressure. If you're not a chemist, vapor pressure equals atmospheric pressure when boiling occurs. Substance should boil. So I'll get back over here and we will start that. Sugar, the maize carbohydrate, and this is going to take a little while to drip out of here because corn syrup is rather thick. Sodium chloride, drop that in there, and the water, and I'm going to cheat a little bit here, and I will use the stirring rod to kind of get that corn syrup moving a little bit faster. And then of course, since the corn syrup is mostly sugar, I can actually use some of that water to try and dissolve a little bit more of it and get that into the beaker here. That corn syrup is rather thick. And we will start the Bunsen burner and get that heating a little bit here. A little bit of stirring to mix it up. And the directions do say while that mixture is heating to rub a little bit of the bovine lactate onto the aluminum foil. That comes in later on, but we'll want to get that done real quick here. So I'm just going to take my stick of butter and put a bit of it on the foil. Some of the common mistakes that students have made in the past, not reading directions or misinterpreting directions, some of them would use the pad of butter and smear it all over the aluminum foil, so they would have all of their 7 grams of butter on the aluminum foil rather than having any to add at the end in a later instruction there. As I said, some other things, leaving shells on. Some people would peel the red skin off the peanuts, and they would take so long doing that that the mixture would be practically done or overdone by the time they got the peanuts added. So that's starting to warm up nicely. And I will lower this to give a little bit more heat. Remember, we want to get this up to boiling. Right now it's at about 40 degrees Celsius, so we've got a ways to go here. Just wanted to make sure the beaker was heated gradually here so it has time to adjust to the temperature rather than a cold beaker going over a hot flame and shattering. And this is one of the few labs that I had special glassware set aside for that would not be contaminated by chemicals. We'd only use the glassware for this particular lab and make sure everything was washed, sterilized, and licked clean by a German Shepherd before using it. And I don't know if you can tell, but that corn syrup mixture is getting quite a bit more liquidy rather than syrupy. And it's heating up fairly rapidly here to about 70 degrees. And I already have the material measured out here. That, of course, would always take a little extra time for the students to do. And usually, if they divided up the lab duties among 3 or 4 people in the lab group, they could get it done in the right amount of time here for a class period. Up to about 90 degrees, and I'm starting to see a few bubbles down there in the bottom. Just where I'm setting my stirring rod. About 96 or 97. And you can see there, hopefully you can see there, it's boiling somewhat freely now. So as it's doing that, I will be adding the legumes. In case you didn't know that peanuts were legumes. And if you get a chance, read a book about George Washington Carver. Peanuts are a wonderful thing. But then again, so is sugar and many of the other materials that we have here. And we're going to continue to heat this according to the directions until the The average kinetic energy of the mixture is approximately 1.5 times the normal boiling point of pure H2O. So pure H2O's boiling point is 100 degrees Celsius. We want to get this up to 1.5 times that, which would be 150 degrees Celsius. So we've got to get it quite hot, and part of the reason for that is that water that we added and that nice liquid mixture that we had. We actually want to gradually get rid of that water and the water that's in the peanuts there. These were raw peanuts that I used. They were the Spanish variety, but they will also get rid of some of their moisture as this gets up to 150 degrees. Hopefully we'll drive out most of that water. We're up to about 110 there. And this is usually the point where the lab gets a little dragged down, because if you can see some condensation here on the inside of the beaker. Like I said, it's going to take a while to get rid of that water, allow it to boil off. So this is where the temperature does not rise quite as rapidly. And when the temperature does get up to that 150 degrees, we're up to about 115 here, I'm going to add the bovine lactate, the butter, and the baking soda. And part of why I like doing this in a beaker instead of on the stove in a pan is the beaker lets you see what's going on there. It lets you see the boiling, it lets you see the bubbles coming up from the bottom, lets you see the peanuts, and the best part is the addition of the last two ingredients and the change that it kind of undergoes rapidly. Before we pour it out onto the sheet to cool. And Austin might want to edit this a bit so you aren't waiting around a long time for this to get to 150. About 120. If we have any Herscher High School alumni watching that remember doing this lab or appreciated this lab, you can let Oscar and myself know through the library. I kind of enjoyed it because I got to laugh a little bit about how some people cooked and which ones turned out well and which ones turned out poorly. And I got a rather intense sugar high from testing all the peanut brittle that the different lab groups had made. Approaching 130, and it's starting to rise a little bit quicker now because you can tell we don't have as much condensation there, so the beaker is pretty hot, and a lot of that water is gone, so now the sugar itself is going to start to rise a little bit rapidly, up to about 135. And of course, if you take sugar too far, you burn it. What we are trying to get it to is kind of what we call a cracking temperature, where when the sugar cools down, it's going to form almost like a glass-like appearance or texture, and be easy to crack. 140. 145. Almost up to 150. I'm going to see if I can bring this a little closer to the camera. So when I put in the baking soda and the bovine lactate, you can see a little bit better what is going on there. We are at 150. Take it off the flames. If a pat of butter would come off there. There's the butter. There's the baking soda. And we stir it up. We get that nice brownish color from the butter and a bit of foam. And as I'm using the thermometer to scrape this out, onto the sheet here, I'm going to spread that out a little bit with the thermometer on the sheet so it's a little bit thinner. Set my beaker down over here. I don't know if you saw there, when I started to move my beaker, there's these glass-like strings that are coming off of there that actually I can show you with the stirring, with the thermometer here too. There's a few of these strings that you can kind of just keep pulling, and they can get to be quite long, but they are pretty much pure sugar, and you can taste them. This is still quite hot, so I'm trying to go slowly here. Some of the mixture that's on the stirring rod, there's kind of a glass-like appearance, and if you get a wide enough piece here and pull slowly enough, kind of looks like a bit of wax paper, or not wax paper, but clear wrap coming off there, and it can break off like that, and that is very good to eat. Now it's got a nice crunch to it already as it's cooled down. So this is our peanut brittle on the aluminum foil, and we'll just set that over on the windowsill for a little bit to cool down before we crack it and sample it. Okay, and I have retrieved the peanut brittle from the windowsill where it's been cooling down, and it should be cool enough to where it'll break, it'll crack into various size pieces. So one of the things you look for is that nice crack. And then of course you have to taste it. And it is good. Some people like to cook the peanuts ahead of time or cook it a little bit longer. It is kind of neater when you add the baking soda and the butter, if you get it a little hotter than 150. And part of the hard part here is the cleanup, because of course that beaker now has a bunch of solidified sugar on it, especially up around the rim where I poured out. So I'm heating water up on the Bunsen burner to dissolve that, and that'll take a little while. That's one of the tedious processes. If you do it in a pan at home, then your pan can just sit in the sink with some hot water in it, and as that hot water gets cold, put some fresh hot water in it. It'll eventually dissolve. It's just sugar. So that is our peanut brittle lab that originated years ago at Herscher High School. And thanks for watching. Get out and enjoy doing some of this stuff. Have your kids help you make peanut brittle, bake bread, do anything that is related to chemistry. Thanks. Bye.